Hi everyone, this is Larry from Fix. Today, I teach you how to use a multimeter to repair a malfunctioning machine with CXW. That is how to use and measure with multimeter. Switch to the actual operation screen. First, I will teach you how to use the multimeter. First, you can see the multimeter. This can be a knob button. There is a sign on the top here. Off is closed. In mobile phone repair, which ones are generally available? Only use this logo, remember it. This logo is buzzer gear and diode gear, which belongs to a composite type. Because this is an auto-ranging multimeter, this is the off state. We choose here first. This is the on gear. There are signs on this. One M and one earphone are on 5. This is not used during mobile phone repair. Here is a select button. Click to switch. Here is an on and a buzzer sign. We see this buzzer sign. This kind of mark is a buzzer gear. What is this gear used for? Let's take a look. If the two pens are connected, the multimeter will make a beeping sound. This gear function mainly measures the connection of the line. For example, a screwdriver. Check the connection from here to here. We look like this. It will be having a sound. This is the state of a connection line. If a line is disconnection because our fingers are insulated, it won't be having a sound. Just like there is a disconnection in our motherboard. We use a measuring pen to measure. It is having a sound. The line is connection. It is the connection line if it won't be having a sound. This is the first step in our multimeter repair. Then we choose and click. We see this V sign and a sign of diode. This is the diode logo. This is our diode gear. This gear is used to measure resistance. This resistance represents the continuity of this line. If there is a resistance value, it means that the line is connected. If it is all L, it means the line is open. If it is not connected and some places are disconnected, if short circuit, for example, if our 2 meters are connected, it is short circuit. Short circuit is 0.002. Some tables are 0.001. It depends on the value of your measuring pen connected. Now, if we measure the voltage, you can see the V on both sides. This is direct current. This is alternating current. We must use direct current during maintenance. This is the voltage measurement gear. What is the difference between these two? Let's take a look. If in this gear we measure the ground resistance, when measuring the resistance, the red pen is connected ground in place. How to find the ground in place? The surface of the chip can be the ground in place. Then these car slots, sockets, iron sheets, these are all grounded. Let's just measure one. You can see that there are numerical values. It means that this point is normal on this road. This is how we measure the opposite resistance. Then, if we measure the voltage, remember that we choose the DC voltage. Black pen grounding, red pen measurement. This is the opposite of our measurement of resistance. Then enter the repair process. Let's study in detail. This is a faulty machine that does not show up. Encountering this kind of machine without display, our first step is to check whether it is turning on. DC power supply meter. To see if its motherboard is turning on. We can see our success motherboard. This is only a board. Now first learn how to boot the board in the case of a single board. This is the boot connector. First of all, these connectors must be recognized. These connectors will be marked on each drawing. Then see the CXW drawing. The drawings are divided into several categories. We can see Huawei, iPhone, iPad, Oppo. These are the classification of the drawing model. First, see iPhone. First, see the success phone we are going to repair today. You can see many models above. iPhone models are very complete. Find success and click. Then find AB. AB shows a drawing on both sides, A and side B. We open it. But you can go and click to see this. You need to use the CXW software more. So how do we turn on this board? First, determine the boot connector of the motherboard. Direct find the motherboard boot connector J4700. Click on the line inside. The following is the translation of the line. Then we can see here to find this row. There is a whole key in the middle. This is the boot trigger point. So how to trigger it in the case of a single board? We use tweezers. One end grounded, one end touch the signal pin. The signal of the power on button will trigger. Now switch back to our 4 cameras to take a look. First, look at the power supply. This is the battery holder. See the power current. You must first buckle the power button of this power connector. We buckle it up. After buckling, we move to the power button. Enlarge the CXW drawing. We see the whole key in the 4-pin. Whole key. The pin is about the power on triggered pin. The second one from the right is. Now we can see. Put an end on our start trigger signal pin. Then one pin is grounded and there will be a starter current. Everyone can see the DC power supply meter has a value by looking at the 4 lanes, but now has been triggered to power on. We can find a lot of grounding places. This ground, 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 ground. The iron place is grounded. This is the boot current, everyone remember. Now let's take a look at how the current is normally turned on. After just observation, the boot current of this mobile phone motherboard is normal. Let's trigger it again for everyone to see. Let everyone remember this boot current. The normal boot current of all iPhones is roughly the same. Everyone, look at the 4 lanes. Start to jump right now. At this time, when the twisters are touched, there will be a jump from 0.07, 0.08 current at this time. If it is a normal phone, the screen is already on. Above 1A means this phone is turning on and ready to enter the system. At this time, the current decreases, indicating that it has entered the system and is in the lock screen interface. The lock screen current is relatively small. During the boot process, when the white Apple logo, there will be more than 1A current performance. Show it again. 0.07 start to jump. Then jump up complete. Join to 0.138. At this time, the current is probably maintained to about 0.28. Wait for a while, the current will start to rise. Pull up to above 1A. I have just seen the above 1A. It is already powered on at this time. The current will drop a little after turning on. Keep it at a low level of around 20 mA. This is the current response after entering the system and on the lock screen. This is normal current. And this current is the current that can be turned on. This is the true for the normal boot current of all iPhone models. Everyone must remember. Next, we already know the conclusion. This motherboard has been turned on, but it does not display. So what do we do in the repair process? The first step is to change the LCD screen to test. But this phone has changed the screen before and tested the screen is not the problem. Next step. We can think of where to connect the screen. It is transferred to our screen display through the screen connector. So the screen connector is the first step to check. Now need to check the screen connector of the motherboard. Let's take a look at the CXW drawing and find the display connector J4200 first. The first step of our hole is to measure the ground resistance of the connector. Usually, measuring the resistance can clearly find the faulty line, because there are many lines on the motherboard. The fault is not displayed now. So the first place to check is where the motherboard connects to the screen. The place where the motherboard connects to the screen is the J4200 on the motherboard. This number is in iPhone 6s. Other connectors should be viewed according to CXW drawing. Then we have to think that the first step is like this. The same is true for other functional failures. We also need to measure which connector the fault corresponds to. We measure the resistance of the connector. Reduce the scope of the fault to a certain line connected to this connector. Next, we need to learn the resistance on the CXW drawing. Need a reference value. At this time, the CXW drawing plays an important role. We need to follow the resistance on the CXW drawing. Let's check its value. Let's switch the lens. Then we can see this drawing on J4200 connector. These are the numbers that represent the connector. Now you don't need to look at the pin position, you need to look at its resistance. See these three options on the right. This option is NC. NC stands for empty pin. This kind of pin underside have not lines connected. You can see that after checking this, the three blue areas appearing here are the NC pins. The NC pin does not contain any lines. There is no resistance value to its resistance. Next, we press the second option, GND, open. The gray color now, this is GND. GND is equivalent to the value of 2 pins connected. GND means grounding, because the currents form a loop on the motherboard. Some unit circuits need a grounding pin to make this unit circuit loop. The third is the resistance year. The resistance value we are talking about is actually the diode year. So by measuring the value of the year of this diode, we can know if the value is correct. It proves that there is no problem with the continuity of the line. The connectivity of this line is intact. Proof that the components of the line are also intact. Now use real objects to measure. Switch lens. Next, use this board to measure the display connector. We find out where it is faulty. The first step must be to reach this diode year. We need to measure its resistance. Then we press this to switch to this marked year. Then the red pen is grounded. This iron sheet and screws are grounded. Black pen to test the resistance of this connector. Just now we mentioned that the location of the J4200 is where the display connects to the motherboard screen. This is the display connector. Then we need to use a black pen to measure the resistance of the upper pin of this connector. Then put the multimeter here to measure under the microscope, otherwise it is hard to see. We operate under the microscope. First, see the CXW drawing. Both sides are grounded. We use this red pen to ground. Then measure both sides. 002. Two pen connected. Also 002, 001. 001. This is GND, which is normal. This GND will not cause malfunctions. So this key does not need to be checked. GND point is grounded point. Just the same as the line on the drawing, it is okay. Then we look at other useful lines. We measure from the top. We start measuring from here. First, we measure the resistance of the first pin, around 460. 443 on CXW drawing. The deviation of these resistance values is normal. The resistance measured by each multimeter will have a little deviation, because this resistance is related to other factors such as the current temperature. As long as the deviation of the resistance value is not particularly large, then if the resistance of this line is normal, the line is normal. Then we measure the second one, more than 600. About 500 on the CXW drawing, it is normal. Next, OL. OL on the multimeter. This line is also normal. Let's measure the next one, more than 300. More than 200 on CXW drawing, these are normal. Deviation are normal deviations. Then measure the next one, more than 600. More than 500 on the CXW drawing, normal. The next, more than 400. There are more than 300 on the CXW drawing, which is normal. The multimeter is pulled up by an average of more than 100. Measure the next one, more than 500. There are more than 500 on the CXW drawing, normal. Next one, OL. Normal, OL on the CXW drawing. Then another empty pin. Empty pin is also OL. NC corner is also an OL, everyone remember. The next one is the grounded pin again. This is the ground pin. The resistance is also normal. Measure further. This is our grounding pin just now. This has no resistance. There need to be resistance on this CXW drawing, 319. In our actual measurement, there is no resistance. Now we know a place with no resistance, with problem. Look at the resistance on the other side. This is also no resistance, remember it. Remember the 23 and 21 pins. First, measure the next. GND is normal. We look at this. There is resistance. This is normal. There is also resistance. Then measure. GND is also normal. And then measure it down. There is resistance. further down, there is resistance. GND further down is normal. And the last three. One, two, three, all have resistance. We just saw pin 23 and pin 21 originally had resistance. There is resistance on the CXW drawing. Actually, there is no value measurement. It's actually measuring OL. Remember pin 23 and pin 21. Because there is still a row below, we directly measure it and then check this line. We start from here to check. The same, red pen grounds and the black pen to measure. Normal. 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 OL is normal. Normal. Next. Normal. 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 Then we need to move the CXW drawing over. Normal. 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 This row is all there. Normal. Normal. All have resistance. There is an OL. We correspond to the CXW drawing. Normal. Let's go to the right. Pin 18, normal. Pin 14 are also available. Pin 12, originally OL, normal. Pin 10 are also matched, normal. Pin 8, no. Look back. NC is normal. There is no last OL. Look at the original OL. Then we can draw a conclusion by measuring the connector. There are three abnormalities. The first one is pin 23. There are pin 21 and pin 8. Let's measure it in detail for everyone to see. Let's see if these three pins are abnormal. Let's measure. Let's take a look at the 8 pin, the 4 on the right. You can see that it originally had a resistance of 320. Now it shows OL, no resistance. So the line connected to pin 8 is problematic. Let's measure our 21 and 23 pin. Let's take a look at pin 23 first. There is no resistance. Then let's take a look at pin 21, which has no resistance. It can be concluded that this connector has 3 failure points. And these 3 places are OL. OL means that the line is open and disconnected. The continuity of this line is problematic, and the connectivity is problematic. So, it is the component of these 3 lines that cause this failure. So we have to check all the lines on the display unit now. Only 3 lines were found to be abnormal. We have narrowed the point of the fault range to these 3 lines. And we have found that there is a problem with the lines connected to the 8, 21, and 23 pin. OL means no connection. There is a problem with the connectivity of the open line. Please note that we have a reminder here. If the original CXW schematic show a resistance value, there is no resistance value now. There will be 2 situations. One is OL, our current fault is OL. OL stands for open circuit. The common fault point of OL is the inductor and IC. There are a few cases on this connector. When the original circuit has resistance value, when encountering this kind of failure, we must first check the inductor, IC, and connector on the line. C capacitor and R resistance will not cause OL. If there is a ground short circuit, such as 002 or 001, it's proof that the line is short circuit. If the original value becomes a short circuit, it's proof that the capacitors and IC of the circuit are problematic. Frequent failures are generally on these 2 kinds of components. Next, we proceed to the next step of testing. First, we see the drawing of pin A and we can click on the CXW drawing. We can see the line above. This SPI is about the touch line. This touch line is not the direct cause of our mobile phone not displaying. But this line is problematic. Even if it can be displayed, there may be no touch function. We also need to repair this line. Switch lens. This MIPI line, LCM data. This is the positive data connector port from MIPI to the display. This line is responsible for the display function of the mobile phone. LCM is a line related to the mobile phone display. We can see that pins 23 and 21 are connected to the same dual inductor. L represents the meaning of dual inductors, which is a 4-pin conductor composed of 2 inductors. This is a separate inductor. Here is also a separate inductor, which is equivalent to this inductor is integrated. You can see that the place where the 23 pins and 21 pins are connected is the L4201 inductor. So the next step is to check if there is a problem with this inductor. Then we also take a look at this pin A. FL model is also an inductor, can be shortest jumper. It is a protected inductor. We will test it later. If the inductor becomes loose or burning out, then this line will have no resistance, which is very common during maintenance. Specifically, you can see how to operate the physical board. Look at 23 pin and 21 pin first. We can see that there is a crack here, so there must be a problem here. Let's remove the glue on the top. We can see that the inductor is already loose. This kind of inductor can be shorted. We don't need to bother about it. We first remove the nearby glue, and then we measure it. This inductor is next to the display holder. Let's measure its resistance to ground. Adjust to the diode gear. We first look at the 23 pin. First, make sure that the connection line from pin 23 to L4201 is normal. Let's check the resistance first. There is no resistance here. There is no resistance here either. So let's test here. There is no resistance. There is no resistance either. At this time, how do we judge whether the connection between pin 1 of the inductor and the pin 23 of the connector is normal? Pin 1 of the inductor to pin 23 of the connector are connected. How do we judge whether the two red dots are connected properly? We can switch to this buzzer gear. We put one pen here and another pen here. It will ring. Then we look at this again. It will ring too. We use the buzzer to measure the sound at both ends. Then it proves that the connectivity between the inductor 1 pin to the connector 23 pin and the inductor 2nd pin to the connector 21 pin is normal. We say that L is to connect. This is equivalent to 2 small inductors for connection. Of course, this component is loose now. Then it must have no connection function now. But now we need to connect this and connect these two. Let's first measure whether the resistance to ground of the inductor pin 4 and 3 is normal. If there's value, it proves that the lines from these 2 points are normal. If not a normal value, we will reduce the CXW drawing to C. There is a small red dot here, which proves that it is connected to the CPU. You can see that pin 1 and pin 4 are in the same chip, and they are on the same side, and they are connected here. So we have to see that there is OL, but here is resistance. So the 23 pin of the display connector is connected to the first pin here and then to the 4th pin here. The number 4 pin has resistance, so the number 4 pin is connected to some other components. Let's click here to zoom out to see where this line is connected. You can see that there is a red dot here. It is connected to the U0600 CPU component. So we have to measure it now. The resistance of the diode value on pins 4 exists. If it exists, it means that the line it connects to CPU is normal. If the resistance value shows OL, then it's proof that it is disconnected from the following component. So if the diode resistance, all this point is OL, this proves that the connection between pin 4 of the L4201 and pin A3 of the CPU is disconnected. If this is the case, we need to jumper the line. If we measure the ground 001 or 002 shown here, it proves that there is a short circuit in the components behind here. Then the lines from here are only connected to this chip of CPU U0600. That means this point and this plate is a short circuit. So now we have to measure whether the resistance of pin 4 of this L4201 is normal. Let's measure it now. As you remember, the red pen is grounded and the black pen is measured. Remember to turn our multimeter to diode position, because what we are measuring is the resistance of the entire line. We need to adjust to the diode position. You can see the resistance appears. This proves that this line behind pin 4 of L4201 is normal. In the same way, we will also measure the number 3 pin next to it, which also has resistance. This proves that the line behind the 2 pins is normal. The problem is that there is a problem with the line connection between the second pin and the third pin of the capacitor. And there is a problem with the line connection between pin 4 and pin 1. Because we have tested the resistance at 2 points here, it proves that the line connected after side is normal. We also have measured it with the buzzer file before, and the pin 1 and pin 23 of L4201 are connected. Because there is a sound coming out, proving that they are connected. It is normal to use the buzzer gear test between L4201's number 2 pins and J4200 number 21 pin. So now the point of failure is the connectivity of L4201's number 4 pin and number 1 pin. Problems with the connectivity of the third pin and the second pin. Because the integrated inductor is next to the display connector, the inductor may be loose when the screen is connected, causing the fault. If the screen voltage charging will also cause this inductor to burn, causing it loosen. So we usually follow this step when checking. The first step is to check this connector, the functional connector. If there is a problem with any function, check the connector of which function to see which pin has the problem. Then we narrow the fault point to the line. Then we can troubleshoot more easily and conveniently. Let's process this L4201 first. Because this L4201 is an inductor, we don't have other L4201 components on hand. Remember that all L and FL can be shorted except for the boosted coil of the boosted L. Then we will directly connect the number 4 pin and number 1 pin of this L4201. Use jumper wire to connect, and then use jumper wire to connect number 3 pins and number 2 pin. Then we will jumper it on. First, let's deal with the pad. We add some thin paste to it. We use a soldering iron to remove the old solder joints on the pad. Now connect it with a wire. If you cannot jumper in those big solder joints like this, we can directly connect the 2 points with tin. Because the purpose of our jumper line is to connect 2 points together. We can directly use tin to connect it together. Let's show it once again using jumper lines to connect 2 points together. Another time we will use tin to connect them together. Then we can go and add a little tin. Let's add more tin. After we hot and round the solder joints, we solder the wires on. That's fine. Then handle the other side. We first cut off the excess thread with a blade. And then jumper another point. Why do we need to add tin in the first place? Because we are adding medium temperature tin, 183 degrees tin. It will be easier to solder, and the main action of our jumper line. Actually, use this tin to connect the solder joints with this wire. Let's take a measurement of the jumper. Then we use PCB water to clean it to remove the excess tin. We will measure it after cleaning. We adjust to the diode gear. We can see that the resistance is back. Let's look at the other side. The resistance is also. Then by short jumper, the fault of pins 23 and 21 are solved. The fault of this line has been solved by us. First, let's test its display function. And we just mentioned it that there is a problem with pin A. Pin A is the touch line, but it has nothing to do with the display. Now, there should be a problem with the touch, but the display is normal. Let's test this machine. You can see that the boot logo appears. Proof it is normal. Let's take a look at the system. You can see that the display is fine, but the touch is not normal. In fact, I already knew the answer when I just measured it. So let's go back and fix the problem with pin number A. Disassemble. Because pin A originally had resistance, it is now OL. Proof that the line connected to pin A is faulty. Then let's take a look at the line of the A pin. First, it is connected to this FL4251. First, rule out whether there is any false welding in the connector. You can take a side view of the microscope. You can see that these solder bolts and pins are good and full. So it is not a problem of loose connector. Sometimes when the connector is changed, the connector may loosen. Then we directly lock the fault to FL. The fault is locked on the FL4251 line. Okay, let's remove the glue again. You can see here, FL4251 is connected to pin A. Then the other end of this FL4251 is connected to this C4251. Then this C4251 is grounded. They are like this. They pass through here from the A pin, pass through the other end, and then pass through the C connection to form a loop. However, this line originally had resistance. Now it is OL. We say that OL will only appear on poles, chips, and connectors. C will not cause. So basically the point of failure is this FL4251. Look at this 4251. As you can see, it has a loose state. Well, we pick it out. Let's take a look at some small components around. Touch it to see if it will shift. The component next to it will not loosen even if you press it with tweezers. So this FL4251 is problematic. It is loose, causing problems with this cable. Now we need to deal with this FL4251. So we need to clean up the glue nearby. Okay, this time let's test if the other end of FL has resistance to ground. Number A is connected to this position. We measure whether the other side is normal. As you can see, the other end has resistance. This end has a resistance value, which proves that it is normal to connect these ends to C and then to D. Okay, as you can see, we go to the following. As you can see, it has another side. In addition to connecting the C, the other end of the FL4251 is also connected to small components below. Through the other end of this component, we see where this R is connected. It is also connected to the CPU. So if we go to measure the other end, it sure has no resistance. We need to check the CPU or R. If we measure this point, the FL4251 end is connected to pin A, and the other end is connected to C, R, and CPU. So if you measure this point, the resistance is grounded or there's no resistance. It proves to be the problem of R or CPU, or even the bottom of the board is broken. If OL appears, it proves that there is a problem with the connected chip. Because we say that OL is caused by inductors and chips. Then this line is only connected to the CPU IC. At this point, the resistance value we measure is grounded. Then it will only be caused by C and IC. C is the capacitor C4251. IC, this is the chip. Okay, let's measure this point now. So now this fault, we short jumper it. In the same way, first add solder paste. Then make these two solder joints a little rounder. After the solder joint is hot and round, we will jumper it. Short jumper. After connecting, cut off the excess wire. At this time, let's measure whether the pin has returned to normal. Okay, we can see that the resistance at this pin is back. Next, we install the machine to test whether the touch is normal. Okay, you can see that the touch is restored. The malfunction described by the customer that the mobile phone does not display has been repaired. However, after the repair, we still need to test this function. Wi-Fi, Bluetooth, sound, camera are all normal. Next, learn how to measure voltage. Take the camera power supply to measure the voltage. To measure voltage, you need to connect the battery or connect to a DC power meter to measure. Or go to connect DC power meter. We connect the battery and turn it on. Find a line to demonstrate the voltage measurement. Choose a row here and see. Switch to CXW drawing. We click on these lines above. We can see that 1.2 volts is displayed below. Look at the others. There are 2.5 volts and 2.85 volts. This is 2.85 volts for camera power. Let's measure whether this line has power. We adjust to this position to measure the voltage. Please remember to measure voltage with red pen to test and black pen to ground. Find the A pin, then ground. There is no power supply here. Back here to measure. There is no power supply here. In fact, this situation is easy to occur when measuring voltage. Because we need to connect the camera, we can measure the result even when we need to use this function. However, there is no position measurement after we connect the camera. So we need to find another location. This is PPBCC max, which is a very common line. This line will have a voltage as long as it is clamped on the meter, and it will have voltage when connected to the DC power supply. Then we will measure the voltage of PPBCC max. As you can see, there is a voltage of 3.8, which is the voltage of PPBCC max. This voltage can also represent the voltage of the battery. It shows that the battery has a voltage of 3.8 at this time. This is also a way to measure voltage. In some places on the front, you can see a negative sign on the watch. At this time, you can look at the CXW drawing of the iPhone 6. You can see PN. PN represents the voltage of the negative power, and PP represents the voltage of the positive electrode. If we measure the kind of circuit with multimeter, the multimeter will display negative sign. Now we know what happens with our resistance. At the same time, we also learn how to measure voltage. So in the multimeter, sometimes it encounters a short circuit. For example, there is 1393 in this resistance. If it is shorted, we measure it was grounded. How to repair this situation in general? In the case of grounding, FL does not cause grounding. First, not care about it. If one end is grounded and the other end connected line is capacitor C, the entire line will be grounded. Why? Because one end is grounded and the other end connected line. If this capacitor is born, it will be connected. Connected will cause this line to be grounded directly. We can find another one. As you can see here is C, one end is line and the other end is grounded. So in this case, it is easy to short circuit. We can also look at the chip. Chip also will cause short circuit by chip itself inside short. But it is artificial. How is it caused by man? This thin ball is bigger. For example, this line and this D4, the solder balls are bigger and they are connected. Will also cause this line to short circuit. This situation is generally artificial. It is not artificial. It is a fault caused by grounding and the beginning of capacitors or chip itself short. We can also use a microscope to see if it is burning or damaged. If it is damaged, the electricity capacitor can be removed, and it does not need to exist. If a short circuit occurs, the C on the line can be removed. No need to reinstall a new one and no jumper line. As long as one end is grounded and the other end is connected to the line, it can be removed directly, because most of the short circuits are caused by DC. Zoom in. As you can see, this C has a red connection line on one end and a gray ground GND on the other end. This type of C is very easy to cause a short circuit. This is that most of the short circuit false points are at C. You can also see that there are some C which are connected to the lines on both sides. For example, this C1555, it is connected to the line on both sides. If both ends are yellow, it means that C1554 at both ends are connected lines. It is different from the ones next to them. One of them is gray and grounded. Can be removed directly because one end of the ground will cause a short circuit. But this C with both ends connected to the circuit will not cause a short circuit. And the C with both ends connected to the circuit must be kept on this motherboard. Switch screen. Okay, so what we give to you today is to learn how to use the multimeter with CXW drawings and how to repair it. If you encounter a malfunctioning machine, you can troubleshoot it like this. At the same time, you will accumulate more and more experience. Then the most important thing to learn about the use of a multimeter is diode gear, buzzer gear, and voltage measurement gear. These three are the most commonly used for mobile phone repair. The others are basically not used. So we need to be mainly familiar with these three gears. In addition, our CXW drawings are also very useful. If you are fine, you can click on the CXW drawing and look at the CXW drawing. Then slowly you will find that the CXW drawings are very useful and very helpful for repairs. Here is a summary of the maintenance ideas, roughly divided into three sections. First, no resistance. Second, resistance. Third, no voltage. If there is no resistance, the common situation is the fault caused by FL. There is also that the other end of the FL may pass through to the chip. Maybe there is no resistance value in the virtual solder in the chip, or the board layer lines from the chip to the FL is broken. There will be no resistance. Usually the FL itself is damaged. The FL is also a protective function. Then we measure it if it is grounded and not caused by humans. Generally, it is a short circuit caused by the electric melting at the beginning of C. We can go and see if it is burned or damaged. If there is, we can directly remove. Of course, if it is not possible to remove the lines connected to both ends of C. 99% of the motherboard is a capacitor with one end GND and the other connection line. Generally can be removed. A minority of lines connected at both ends. So if there is no voltage, usually we measure the voltage is relatively small. When you measure that there is no voltage, then use a good board to test whether the lines has voltage. Like some screens are 5.7 volts. We need to connect the screen to measure these 5.7 volts. Many camera lines are the same. Therefore, we must use a good board to measure, compare, and then measure its voltage. Because the voltage cannot be judged by CXW drawing, we have to take a good board to measure. If there is no voltage on this line, we have to repair this line. The idea of maintenance is the same as no resistance to find its source. Is it caused by chip or by FL and R? You can also find the same power supply jumper and borrow the voltage. Okay, the above are 3 maintenance ideas. This lesson is finished. Goodbye everyone.